Now, again, before we do for I is equal to 0, let's see that whether we can deduce any algorithm so far by solving from I is equal to 4 to I is equal to 1. Is there any pattern or algorithm we can use for I is equal to 0? So let's check it out. So here we started with the last index first, right? Target when I is equal to 4. So it means that our initial thing was that we started with nums dot length minus 1, right? This was our first target. I mean, this is the index that we started with. Because if you see the nums, is the nums dot length is 5, and 5 minus 1, 4 is the, because index starts from 0 in Java. So that's why it's 4. We started with index of 4, and we always saw that it's always going to be true. This was our base condition. Now, once we proceed with the sub arrays for I is equal to 3, 2, and all, what we were checking is that for that index, right? If I start with index I, if this I plus the whatever the value is there at that index, for example, if at nums of I, we see that if it's greater than equal to target, right? So what I mean is that if I, suppose I'm just considering at this position at index of 3. So if I is 3 plus nums of 3, which is 1. So 3 plus 1 is greater than equal to the target, right? The target here was 4. We're talking about indices here, guys, not about the value. So I is 4. And here we checked at this position that if I plus nums I, so let me again break it down. So if I is 3 here plus nums of I is 1 is greater than equal to 4, right? Which is target, and this gives me true. That's why we got this condition as true, because 3 plus 1 is 4, 4 is equal to 4. So this condition stands true, and that's why we marked at index I is equal to 3 as true. Now again, using the same formula for here, so let me write it down here, that if I is equal to 2, so our new target has been 3, right? Because we also need to change our target. Once this condition is true, our target revises from index 4 to index 3. So maybe I will better write it down like this, that if so here I've just written on the pseudo code that what we just discussed, that if I plus nums I mean at index 3, I is 3, 3 plus 1, 4, nums of I is 1. So 3 plus 1 is equal to 4. Then we revise our target to this new index, because as we discussed that this will be our new index. If we are able to reach from 0 to 3 here, we already know that from 3 it's possible to 4. So this would be, we only need to check whether we are able to move from 0 to 3. That's why it was marked as true, and our revised index target becomes 3. So it was 4 here. I will just mark it here to make it more readable. And so let's go. Also, I will move this formula to maybe here, so that I can write it down for all the cases here. Okay. Now let's go to I is equal to 2. Again, if I choose 2 plus nums of I, nums of 2 is 1 again, right? Which is greater than equal to our revised target of 3, which is true again. And our target then becomes I is equal to 2. So this is what we are moving our target to by just reducing this algorithm based on the observation that we have done so far. Now again, for I is equal to 1, I will use the same formula. So 1, I is 1, plus nums of I is 3, right, is greater than equal to the target of 2. So we are 4 is greater than 2, right? So it's true, and that's why we have marked it as true. And our revised target becomes index 1. Now let's do for the final solution, that is I is equal to 0, right? Again, if I use the same formula, it would be I is 0, right, plus nums of I is 2 is greater than equal to our target, which was revised to 1, index 1. So 2 is greater than or equal to 1, which means that the last target is 0. And once we are able to reach to this position 0, it means that we are able to move from this to this position. And for this, we already found that I is equal to 1 is equal to true. So this is our final solution, true. And this would be what will be resulting into. Now for the other case, right? I mean, we have already seen the other case as well. For example, say 0, 4. Here, if I take this example, for example, I just put it here somewhere. Okay. Now here it's mentions that it was 4 and here it's 0, right? 0. So here in this condition, if we reach, we are never able to move any jump from 0 to 4. If I just treat these two arrows, these two sub array, so our condition fails here only, right? Because if my start position is 0 and end position is 4, it means that there is no way I can jump, because 0 means that there is no jump possible from this index position. And we've already seen that from all the previous indices also, whatever I'm just taking 1, 2, and 3 here, right? Whatever jumps we take from these indices, we only end up to 0. And from 0, we already calculated that it's impossible to move from 0 to 4. So this formula works here for all the conditions here. And this is the final algorithm that we have deduced. We start with target is equal to nums.length minus 1. Then for each of the indices, we proceed from 4 to the index of 0 using this formula that we just deduced. And finally, if we are able to reach target as 0, we simply return it as true if it's 0, if we are able to reach at 0. If you're not unable to reach at 0, we will return false. So this was all about the bottom-up dynamic programming approach. In the next video, we will solve this problem exactly the same algorithm that we have calculated here in Java and submit it in LeetCode. So see you all in the next video.